Alright, for the last couple examples, I wanted to look at some problems and I wanted to kind of put together what we've done in the last 4 or 5 examples. So when we look at this problem, we can see that this is going to have an x-intercept because there's an x here, and we can see that it's going to have a y-intercept because there's a y here. Now, the difference with this is we can't have a line that goes both vertical and both horizontal at the same time, so this one's going to have to go on a diagonal. Now we could go ahead and do our table like we've been doing with our table of values, and that would work fine. But another way to do this is to look for the x-intercepts and then the y-intercepts separate. And that's what we've been finding with those horizontal and vertical lines is intercepts. We've just been finding them one at a time. So now this time what we're going to do is we're going to start by making x equal to 0. What does that do? Well, if you notice, if I make x equal to 0, my equation becomes negative 2y equals 6. This is very similar to what we were doing in the last set of problems. If I divide by negative 2, I have y equals, negative 2. I have y equals negative 3. And sure enough, doesn't that look like what we were just doing in the last section? I'm going to go ahead and put my point in, but I'm not going to draw a horizontal line. The next thing I'm going to do is I'm going to make y equal to 0. So I'm really working this problem twice. I'm working it once as if it was a horizontal line and once as if it was a vertical line, and that's going to give me 2 points. So I'll make y equal to 0, which is 6x, equals to 6. I divide both sides by 6, and x equals 1. I'll go ahead and plot that just like I plotted the other problem, or the other point. Now, what I can do is these are what are called the x and y intercept of the line. This is going to give me this line right here, and now I've graphed my line. Make sure to put arrowheads on the end, and now we're good.